The answer is 90. But don't worry if you didn't get that, as that means synapses are firing. The most interesting part of the problem is not the 90, it is the ways people get to 90, the different pathways they use.
Do you remember those interviews in San Francisco that we showed you in the first lesson? Well, we also asked the people to work out 18 times 5. We asked some Stanford students too. What was striking is that people work out the problem in so many different ways.
First I'd do 10 times 5, 50, 8 times 5 is 40, so 50 plus 40 is 90.
Okay, thank you.
18 times 5, well, the easy way would be 10 times 5 and then 8 times 5 and then add those together. 90, right? Yeah.
Okay, thank you.
I just times the 5 times the 10 and then multiply the 5 times the 8, get 90.
Okay, cool. Right.
Okay, well, I would probably go up to 5 times 20 first, be 100, and then just subtract, I guess, 10, right? So 90.
Okay, awesome, thank you.
Okay.
I feel like I should be able to answer 18 times 5 pretty quickly, but I can't. It takes a while. I do know it's 90. I think I'd probably do it with the 18 on top and then the 5 on the bottom and then 5 times 8 and 5 times 1 and then add it together. It's probably a pretty slow way of doing it.
That would be 90.
Okay, and how did you get 90?
Well, first I doubled 18, getting 36, then I doubled that, getting 72, and then I added 18 again, so
Okay.
that was my
90.
And how did you do that?
So I take 18 and I have that. 9 times 5, 45. 9 times 5, 45. Add them together, 90.
18 times 5 is 80.
How'd you get 80?
5 times 10 plus 5 times 8. No, 90.
90.
And can you just describe your method of how you got to that?
I did 9 times 10 instead of 18 times 5, because same thing.
Awesome.
We can also see the strategies visually in these ways. So some people said they didn't want to multiply 18 times 5, they wanted to multiply 10 times 5, and they got 50, and 8 times 5, and they got 40, and then they added those to get 90. So what would that look like visually? Well, if we draw our 18 times 5 and say that looks something like this, what they were doing was they were saying they didn't want to multiply 18, so instead they multiplied 10 by 5 and 8 by 5, and that's how they got their 50 and their 40. But some people, they said they didn't want to multiply 18 times 5, so instead they multiplied 20 times 5, which gave them 100, and then they subtracted 2 times 5, which is 10, and they got 90. What would that look like visually? Well, let's imagine this is our 18 times 5 again. And they said, well, I don't want to work with 18, I want to work with 20. So they made their 18 into a 20 by adding 2 on. And then they subtracted that and took it off. So that would look something like that visually. Some people said, instead of multiplying 18 times 5, they said, I'm going to multiply 18 times 2, and I get 36. And then there are 2 sets of those, which give me 72, and then I add my last 18, which gives me 90. And visually, what they were doing was they were saying, here's my 18 times 5, and I want to multiply 18 by 2, 18 by 2, and 18 by 1. So that's what that would look like visually. And then one of the others, I think my favourite method of 18 times 5, is people who said, well, 18 times 5 is really the same as 9 times 10. So what would that look like visually? Let's think, if our 18 times 5 looks something like that, those people were saying, I'm going to work with 9 And then I need to double this and make it 10. And they worked out that area instead. So those are 4 different visual solutions from some of the different methods we heard.
We just showed you the visuals for the strategies people used. Now see if you can match each visual to each strategy.